Good afternoon, everyone. So we will and I'll take you through the session where we'll talk about data protection considerations for the elastic cloud native applications. I am Pankaj Ahire, basically working as a senior principal engineer with Veritas, and my current focus is primarily into Kubernetes production. So with that, let's move on, and essentially this is an agenda where we'll talk about some basics about the cloud native application, the current state of cloud native application. What are the measures and what are the different personas involved into overall cloud native protection space. What are the use cases of data protection? What are the considerations? And that's basically we'll cover all of those things. Let's get started with cloud native. What is cloud native? Essentially, it makes systems resilient, manageable, and more observable. The technologies which empowers organization build and make this happen, or all these different kind of form factors, including public, private, or hybrid cloud. Essentially, it starts with continuous microservices, service mesh, and immutable infra and declarative APIs. CNCF sort of democratizes this state of art patterns to make all these innovations accessible to everyone. What is the current state of these applications? So as we've sort of seen this in CNCF surveys, that the applications truly has gone into the mainstream, where a lot of production are using this, and not just smaller organization, even in large organization also the usage is sort of skyrocketed. As we seen in the keynote, that it's the journey of Kubernetes started with ephemeral stateless applications, but it has sort of moving towards data intensive workload applications that are in a variety of ranges, which leads with large data, AI, ML, as well as analytic applications. And on latest trends where not just new form of cloud native applications, even the traditional applications which are running in virtual machines, that are also being supported in this platform through this new technology or framework called Kubert. So that's the state of the cloud native applications. Let's move to basically the Kubernetes and the elements of data protection. As you could see here, the key thing, as we talked about, the applications are moving towards data and intensive usage. Of course, there is a need of handling or protecting persistent volumes, and that is basically application data. Along with data, of course, there's the metadata that sort of comes in a lot of different resources and the forms which are being supported by Kubernetes through different standard as well as custom resources. In addition to metadata, there's of course the environment, where beyond application, whatever the configurations about the cluster, and essentially any configuration, anything which involves entire cluster protection, that would get sort of covered through environment or disaster recovery scenarios for entire cluster. And third one in this space is basically the application. There's this critical element which is not part of the Kubernetes cluster, but sort of an extension to Kubernetes, where the images which are residing in an image registry repositories, that also needs to be sort of protected. So considering all these, key elements, let's look at what are the different measures of, the protection. So the key measures, as probably you heard about this, essentially the RPOs and RTOs, the recovery point objectives and recovery time objectives. What does it mean? It's basically with RPOs, basically how old backup data you're allowed or you need, and the time it takes to recover is what the RTO measures would be, handling with. So with different personas involved in this is basically application administrators. The application admins, essentially they are managing or knowing applications. They have restricted access to the cluster, and so they do own those applications, so they do have a detailed understanding of those applications in terms of not just protecting, but recovering those applications as well, and to the granularity within the application. Another persona which deals with data protection in this space is infra R cluster admin. As it says, it deals with infra management, and it has a full access to the cluster. It may not be aware of the applications which it will be dealing with, but essentially it will, the admins, infra admins will need a way to protect the cluster, entire cluster or entire cluster infra. And of course, the backup administrators, backup admins basically manages all the plans and policies associated with all this data protection, and they do have limited access to cluster. Mostly aware of, not aware of basically applications. Essentially, it deals with all this data protection policies and where the backup should go and what are the frequency and all this stuff that we'll see in some time. So essentially, all this simplified administration in terms of managing all this respective capabilities required for these different personas would be handled through this. Let's talk about the use cases. As we sort of started with, stateless versus stateful applications. There are a couple of capabilities where GitOps being used as an infra as a code, where whatever the code being used for developing an application, that can be used to create an application. But that will not sort of create this application truly at a particular point in time. But essentially, it will bring back that application to the state where it is being developed, and it will bring it to the starting or init state. Beyond that, of course, all of these applications are being deployed in a cluster, and there are a large number of applications. You need an automated ways of sort of discovering the assets. You don't have to go and pick and select a particular asset that needs to be protected. And all of this needs to be efficient, because since this infra is growing exponentially, the large number of applications deployed within the Kubernetes cluster, and that way you need whatever the state of application in an environment that needs to be reflected and accordingly created in a plan. All of these things leads to essentially sort of protecting an application in a consistent manner. For that, actually, whatever the backup and restore capabilities, the use case would be one of the thing to have consistency being achieved is persistent volumes that can be taken into a point in time, consistent state through snapshots. Again, a standard CSI snapshot mechanism supported for all majority of the storages, but needs to be considered that as a use case in terms of the the storage being used in the environment. And this basically not just consistently sort of backing up application. Beyond the backup, it needs sort of a granular recovery capabilities. Sort of backup at once and then restore to the granularity of restoring a specific metadata, what do you need, or specific volume, or a subset of volume, or a combination of these different aspects. Entire application that can be used as a disaster recovery. In case of disaster happens to the cluster goes bad, could take it to the alternate cluster and sort of recover that application to a new cluster. On similar lines, actually, need a mobility where application needs to be taken anywhere in the Kubernetes cluster, with of course which sort of supports through standard Kubernetes APIs. So it could be on-prem, it could be in cloud, and it could be hybrid. And beyond that, actually, currently there's this volume group concept which is still not stable, but that could be extended to have multiple volumes sort of combined together and create an application sort of snapshot at once, and through that you could take an entire application constituting all the volumes together in a consistent fashion. Additional use cases, it's about what are the applications, the corresponding images, application images, container images that also needs to be sort of protected. Majority of this images sort of stored in external, and some distribution does allow sort of supporting this inside the container inside the cluster as well. The backend for this is typically the object store. It could be sort of protected at that level where it can be sort of picked up from object store and being protected. And the other use case is entire cluster is going down. So this essentially constitutes, as we sort of talked about, the metadata store, which is what the HCDD database. That along with database, there's this certificate and configuration that also sort of can be protected. With this use case, let's go ahead and talk about the plans. So essentially, different organization has different SLAs, service level agreements, and based on that, we talked about different concepts of RPO and RTOs, and of course the cost aspect also needs to be considered, especially if the cluster is in cloud environment, and of course on-prem also leads to the cost optimization if you sort of design the data protection schemes in an optimal fashion, considering all this aspect together. In addition to this, there could be need of large data transfer that needs to be done along with sort of the backup as well as during the store. So other consideration is can use specific dedicated network for the backup and restore use cases. That way, it is not just the backup windows would be achieved or backups are done in a timely fashion. It will not impact on other production application in the same clusters, in the same environment. This storage life cycle, we talked about the source level optimization. The planning should consider about even the destinations of the media where the backups going to be stored and retained. So it needs to be sort of a mix of the different storage through which you could create multiple different copies, which can be on a fast storage, the first, and subsequent copies can be on a slow storage. Essentially, you can use the layering, and through that you could achieve the rule of 3-to-1, where you could essentially make 3 copies total for any backup on the same site to a different storage, and of course the third one is take it to the remote site. And all of these could of course have different retention. You can keep it how long you're going to keep this backups, that would be basically based on this SLAs. And the planning should consider about this critical factor about the ransomware resiliency. Nowadays you've seen ransomware is sort of standard. It's happening everywhere. So backup, how it sort of impacts, because backup is the backups are basically means to sort of deal with any of these kind of attacks, ransomware attacks, to recover the backups. So it is it's critical to protect backups as well. One of the key thing is the backup should give or the system should give an sort of detect these anomalies which is happening in the system, where suddenly the data has increased or data has gone down. So some kind of possible indication or warning of some kind of attacks is being happening. Of course, the system should use encryption everywhere, not just at the source, even destination. And with malware being infected, it could detect the things that could be that could not be, I mean, it is being infected and cannot be restored, or remove those infected entities within the entire backup. And of course, extension to this, you need to protect your entire the backup. So the storage where it is being stored, it can be used as an immutable storage, so no one can destroy that. No one can alter any of the backups. So those are like the blueprint that can be sort of used for any disaster, any attacks, and recovering those. So with this plan, let's go ahead. What are the key considerations? We talked about different use cases. There's no one silver bullets, sort of handles all these different kind of use cases. So keep, the use cases separate, application, cluster, and even the registries, the container registries. So that one, I would say probably one consideration. The second one is automated application discovery. It's not just discovery. Whatever the changes which are happening, sort of reflecting that with the backup and automatically sort of being picked up in a production plans, whatever defined. So it's something like probably could, if you have categorized your application with some kind of tags or labels or annotations in Kubernetes world. Those can be defined, and that way you don't have to change the plans. So plan would be same, and as and when the new entities, new applications being introduced or removed, your plans takes care of those, without changing the plans. So it handles all those addition, deletions in an automated fashion. Not just this, basically, with these changes, it should automatically adjust to the environment where whatever the capacity it has. Based on that, it should do the throttling, where it could increase, the backups, or if there are more number of backups happening, it should not impact the production cluster. It should reduce the number of backups it could happen in the system. And all of these things sort of, needs to be sort of done in an orchestrated fashion with a simplified capabilities for each of the persona we talked about. Has to be done at individual persona level, including the backup admins, the Kubernetes admin. Backup admins wants everything to be done from Kubernetes, whereas Kubernetes admin would like to do everything from Kubernetes cluster with whatever the tool set it's using. Like if it uses Argo CD, needs to do the backup and restore through that. And of course, all of these things needs to be automated through the standard APIs being available. So all of these things can be orchestrated and achieved this entire backup restore to the granular level as well. And of course, we talked about ransomware. In spite of a variety of defenses, there's still possibility of an attack. And if something goes bad, there should be a mechanism where you could quickly sort of go back to the state where entire cluster applications can be restored. So that requires a restore to be done in a faster and a bulk of a restore can happen. Recovery of this recovery scale needs to go up, and it has to be done in a faster manner. So not just the backup considerations, even the restore, and specifically for ransomware, where bulk restore kind of things also needs to be considered. And we touch base on some of these things, but clear demarcation of different personas like Kubernetes admin, application admin, and the capabilities required for that is also needs to be considered. There should be a facility or mechanism that can use to have granular access being provided to all of these personas based on the need of the functionality required for this application. That's pretty much I wanted to cover, and utilize more time, but open up for Q&A. Any questions? Sure. Sure. So I think the question is, what are the considerations for the backup, which with the backup it is valid or not? So there are these, of course, restore is one method where you could restore and ensure everything is restorable. It brings back to the same state. Some people do call it as kind of like DR drill, where they do it very frequently as per their the compliance or requirements. In addition to that, the backup can be verified whether if recovery is not possible. You could sort of validate the backup itself, where the backup it is good. You could scan the backups and see whether it is not being infected with any of the malwares. So those kind of things can be achieved. Sure. I told you.
You mentioned about this configuration files. What is the state of art to scan these configuration files and figure out if there are security issues in the setup possible? So, like, are there any tools that help in, are there good tools to do that kind of?
Sure. I mean, security is the key aspect, and I mean that is one of the next thing in Kubernetes world. This is being widely used. What are the security mechanisms? For specifically for configuration, there are a lot of rule-based things where a lot of hardening of Kubernetes environment is happening, and Kubernetes network policies and those kind of things are sort of helping sort of protect the environment. And beyond that, I mean certain things are can be mandated. For example, do not allow the privilege containers. Privileged containers basically the applications which are using privileged container, they could have access to the infra. I mean, that way actually it can, the malicious entities can take that route and sort of exploit the environment itself. That can be sort of that could be one of the thing.
I've seen a lot of tools being used, but they have got many false positives and so on. But that's the state I thought, but I thought there was something much better solution. So we can discuss later.
Yeah, sure. I mean, backup-wise, from backup perspective, as we, this is just an extension to the previous question, which I've answered. Basically, we could check the validity of the image as well as run it through the scans and understand whether it is being infected. So, but these are like sort of post or backup domain specific activities. Beyond that, at the source level itself, there are like Kubernetes specific things which are which can be used. Yeah. Thanks. Sure.
In Kubernetes world, like application definition is very fluid, right?
Right.
It doesn't need to restrict to a single namespace or a multi-namespace or a single cluster.
Right.
So, how do you foresee, or are there some tools which can span applications which are spanning across like namespaces or clusters or regions?
Right.
So, what are some good, like recommended, or what are some tools that can be used for considering backup solutions for those applications?
Sure. So the question is about the application just spanning different. I mean, application definition is fluid, and it can be within namespace. It could be multiple namespace within cluster, or it could be with different. I mean, some application.
Application like across clusters.
Right. So this is basically there was this probably the amount of seen this. This was one of the question that was come up in a CNCF survey, and I think the majority of the response were where the application is hosted within namespace, single namespace. But then there are some use cases where it could sort of cut across, a multiple namespace within cluster, or it could be beyond cluster. So I touch few points where the application discovery, dynamic discovery, where it should not be restricted to it's just the namespaces, but beyond namespaces within cluster, or even discovering entire cluster and sort of correlating all of this by some fashion. I mean, since you talked about the Kubernetes application is fluid, but there are some recommendation in terms of using those annotations and labels, some standard recommended application naming conventions that can be used, and that can be sort of fit into backup system, whatever you define. That way the protection plans or the the policies whatever we create, that can reflect what is the logic you have defined for defining an application, and that way the plan can take up that a particular application, be it single namespace or different multiple namespaces, or an application spanning across different clusters. And
Are there any tools which checks for this compliance that the application that you have defined is following the recommended names or label selector or annotation method?
I haven't seen that specific tools which anyone probably aware.
Thank you.
Thanks.
Yeah, that's what it's very fluid.
Yeah. Sorry. Yeah, please.
What I'm trying to traditionally we do have this RTO settings or the criteria specific for disaster recovery. Right? I mean, when it comes to the cloud native world, it becomes a bit more different, where it's the overall application recoverability, if I would say,
Right.
which involves the operational recovery also.
Right.
Right. So sometimes now the situation is that cloud native has given you the advantage that you just switch to the other region also,
Right.
rather than doing an operational recovery.
Right.
Same setup,
Right.
So how would you see this data protection kind of things evolve in a I mean, maybe the old school, I mean, I wouldn't say old school, but the backup restore is never been needed in a long run. What are your thoughts on that? Maybe the RTO RPO is getting much better with the cloud native stuff.
I mean, cloud native is sort of providing all of this. I think who have not heard about this question. The question is about basically the basics. The traditional RPO RTO mechanisms were meant for sort of recreating environment and then restoring application. Whereas Kubernetes world, it's pretty much flexible in terms of taking to any other cluster and restoring there. So we touch base few of those things. Essentially, I mean, we could do the recovery flexibility we talked about. It could be the same cluster. It could be alternate cluster. Not just same provided cluster. It could be a different provider as well, as long as that is sort of complies to the standards of CNCF standard Kubernetes API recommendation. Anything beyond that probably will not be understood, interpreted by other cluster. But provided it is able to understand, the application can be recovered anywhere. And that is the flexibility it sort of gives. I mean, that is the flexibility which is coming in the environment, where you could take the application, and again, that boils down to the previous question, where the application definition itself is fluid. If it requires just the particular application that needs to be restored, it can be restored anywhere. Along with that, there are this mechanism where even the infra also needs to be sort of set up. That can come from whatever the initial the templates deployment being used for creating initial cluster. That some of those clusters the same thing can be used for initial provisioning. Same thing can be used for creating the cluster, and beyond that, the backup can be combined together to recover all the applications to that particular cluster. So there are this variety of things which are possible. Sure.
Tell more about the app consistency part of it.
Right.
Way in a traditional backup recovery world, you do app consistency either via going into the application itself and querying the application APIs to say for
Right.
these
Right. Right.
basically checkpoint your data.
Right.
So that is one way, or say in terms of traditional hypervisors, you go and do the checkpointing at the hypervisor level, then you do it at the storage
Right.
system level.
Right.
Now, with respect to when it comes to cloud native and Kubernetes-based applications, right? So, like the application way still will remain, because application will provide you interfaces
Right.
directly
Right.
to
Right.
the application.
Right.
But what are the tools or what are the interfaces that you use from a Kubernetes standpoint,
Right.
where you can actually do the same checkpointing, which is sitting outside of the application, basically on your platform in terms of the Kubernetes interfaces.
Right.
Which will allow you to take a app consistent checkpoint of those application
Right.
infra, basically everything around that application.
Right.
Like your service deployments to pods to containers, and the containers actually running inside the pod.
Sure.
So that is one bit. And then I believe after that, once we have achieved that, we should be able to use the storage plugins via CSI to
Right.
the corresponding
Right.
volume,
Right.
snapshots and all that.
Right.
So specifically around the app consistency part of it, in terms of container checkpointing or Kubernetes level application checkpoints, what are the tools or what are the interfaces that you see, and what have you used?
Sure. So I'll repeat the question for all this. Traditional world, there are methods through which you could do the app consistency. What are things in a Kubernetes world and cloud native world? So I mean the traditional the app consistency part being, I mean there are so many kind of different applications. It's very difficult to generalize application in that sense, and it brings to the point where the application owner is aware of what is the application and how to take that particular application in consistent state. So is aware of some of these things are closed system, which is dependent on that particular application's functionality and the way it works, way it is being designed. So there are certain means through which probably it needs to taken in a consistent state. So the consistency, I mean, as you sort of referred to, consistency can be done at multiple levels. First thing is crash consistency, or the file system consistency. These things are, as you sort of pointed towards, the storage kind of like takes care of the file system level consistency part. Beyond that, the application, as we talked about, the application brings its own the complexities and the way it is being formed, and the different ways of taking it to the consistent level. This this would be difficult to sort of generalize through tools, but at least there should be a tools where it's allows you to define your own extensions along with this the backup schemes, where the standard backup scheme is basically you take a snapshot of the application that involves taking an individual or a group of snapshot together, and essentially there's this middle where we need to flush all this application straight to underneath file system or a storage. So, and that being sort of gray area for generalization, there should be some mechanism or some tools which allows you to extend to your own extension sort of added there with this flow, and not just during backup. And this can be done during restore also. So, and not just before. It could be even after backup, where whatever the consistent state you've taken, you need to sort of revert those state. During the store, you could do similar fashion. So as I said, generalize. I mean, applications. There are a wide variety of applications. Very difficult to generalize it, but some kind of extensions where you could apply your own application-specific consistency logic. Like a lot of DBs have their own ways of sort of taking the particular application in a consistent state through taking some locks. For example, Mongo has a method. MongoDB has a method to ensure a database sort of locked, so that during backup it is not being or when snapshot is taken, it is not being changed. And of course, post backup you need to sort of revert that lock. So those kind of things can be clubbed with those extension scripts, and it need not be a homogeneous script in terms of whatever the tools which is being using in terms of programming language to support all kind of different simple way to sort of automate these steps through script or some mechanism, so that anyone should able to capture these steps, whatever needed for that particular application into script and club along with this.
Kubernetes today provide any kind of interface with these scripts, like what you're talking about is basically pre-checkpointing and post-checkpointing
Right.
that
Right.
can be like customized to your applications.
Right.
So from outside, sitting in, say, like you mentioned, the different personas,
Right.
One is the application owners themselves.
Right.
The backup administrators who are worried about the infrastructure and what they do.
Right.
So in this case, their infrastructure is going to be Kubernetes, and they are worried about Kubernetes. And
Right.
at Kubernetes level, how can I protect my services and applications?
Right.
Not from an application persona, but from here, basically the pre and post scripts are going to be given by the application persona developers or those guys who are
Right.
say you just call these scripts.
Right. Right.
But automating this from a Kubernetes angle
Right.
in terms of protecting this.
Right.
Say now they have given me these are the steps you need to say.
Yeah. So essentially, application will write the scripts, put it somewhere.
So they have given me a couple of scripts which I need to do. So that will take care of checkpointing, and post checkpointing from the application.
Right.
So what then remains is basically, like you mentioned first, restoring the application layer
Right.
in Kubernetes, which may contain multiple different pods. And
Right.
services, right. So that is the first thing. Then comes your actual scripts, calling those scripts. And
Right.
what the
So
application
essentially, it boils down to whenever we're creating those, either policies or protection plans. So there should be a mechanism where along with the flows, the scripts needs to be tied with the workflows being happening with the backup or restore, and of course, as you sort of mentioned about some of those pre and post and those kind of things that can be tied to the plan. And it need not be the plan level. Probably it can be defined at a specific instance of the plan, and that way.
basically define the workflows that you are
Right,
going to run,
right.
basically which your policies are going to follow
Right, and-
as they are getting triggered. So the question is really around, do you see any standard tools or interfaces that Kubernetes allows you to create these workflows and run? I know I can plug into those workflows via these scripts.
Kubernetes.
So they are going to be
So that is more of the backup thing where it allows you to during backup workflow. This needs to be called during backup workflow. So it is not a Kubernetes thing. It's along. I mean, Kubernetes has some ways of sort of providing hooks. But essentially, you want to orchestrate this along with the backup. So with data protection, with application protection. So even with the protection plan, you could sort of extend to include this the scripts, whatever pre and post, along with the plan, and that can be orchestrated completely.
Yeah, so probably we can sync up later. But
Sure.
It is like these hooks and annotations, that is one part of it. I'm asking about the overall orchestration in terms of a framework or an infrastructure which can actually provide you this kind of a capability where that orchestration can be carried out, which can be easily tied up to your policy. So the policy is basically just going to call and work,
Right.
which is going to orchestrate all of this, and that's where in between multiple steps in this are going to be hooks to your pods, and then there is going to be a interaction with your storage systems.
Right.
So that is going to be one other step in that one.
Right.
So
Kubernetes has these things like pre-stop before stopping a pod you run something.
no, correct.
So you can have pre-backup and post-backup, which can
Correct. So these are the
it
immediate
can-
steps that we are talking about. I was looking at more of this entire workflow in itself. Is there a standard framework tools that can allow you to create these workflows? And then basically once you know you've created these workflows, it's just tying them up to your policies. Like every day I want to do this, every week I want to do this, say every month I want to do this. Like
Right.
we should. It is same as traditional backup world. So you're creating those policies with frequencies and all that.
Right.
And in traditional case, it is the application vendor, the back vendor who's
Right.
creating those workflows and orchestrating it
Right.
for you behind the scenes.
Right.
What you see is just the policies on top.
Right. Right.
You don't actually go and do, and now they are giving multiple hooks where you can actually provide your own scripts and all that. So
Right.
that bit is good.
Right.
But still the orchestration of the entire workflow is still defined by the application protection.
Right. Backup. You're right. Right.
So is there any equivalent in terms of Kubernetes, in terms of tools, which I don't think we are there yet, but probably yet.
Yeah, I think.
It is still like, say, if Veritas or Commvault or someone else wants to do this, right? So they are going to still hook on to Kubernetes APIs and different kinds of APIs across the board to build this workflow.
Right.
And
Right.
this implementation is going to change depending on each of the backup vendors. Right? Now, there
Yes.
is no native Kubernetes way of orchestrating this in terms of a workflow, which everyone can plug into. Right? So
Right. I think.
that was my question. Have you come across any tools or any framework or anything in the pipe?
Yeah, this the complexity is increased, and probably heard about that in keynote also. It started with ephemeral, there's no state. Yeah, so the people say stateless. There's nothing state which is stateless. There is some state. So yeah, so essentially, I mean, some of this, other thing. I think Kubernetes, if you see, there's this data protection working group. uh, the same problem being discussed there. Some of these building blocks which are required to do all this orchestration are being built there. One of the thing as sort of referred is this is a snapshot capability at an individual volume level, but application typically uses more than one volume. So creating a group and creating a life cycle of snapshot and sort of managing at the group level. So those kind of things are sort of coming up. Some of this essentially it talks about all the data protection needs on the application, Kubernetes application, not just from snapshotting, not just from application perspective. In fact, optimal reading and writing from Kubernetes cluster to the Kubernetes cluster, all of those things being discussed and sort of formalized there. So it is sort of evolving phase, and there's this plan actually where some of these building blocks are being prepared, created. One of the thing which we didn't talk about, but the optimization requires to have some kind of granularity where you need to know what has exactly changed. So traditionally there's this incremental and those kind of things you could use. Same thing here you can achieve through doing that, but of course you need to first sort of standardize in terms of identifying the exact changes. Those are also being work in progress, which is coming and is being standardized. There are standard APIs being defined for that, and once it is there, it'll be beneficial for any backup basically, or anyone to use those things. Yeah. Thanks.